Hello, buddies. I introduced the design of the WeChat today. WeChat has been a chatting platform in China, and that has about 1 billion users. Basically, it has 4 functions: one-on-one chatting and group chatting, which is similar to the WhatsApp, and the newsfeed and subscription, which is similar to the Twitter. Let me break them down. So for the one-on-one chatting, that has been easy, just 2 users. Each user has a local database. That is the client side. Let's say the mobile phone, and that is the mobile A. And for the other one, mobile B, when it sends out to the server, and this save server handles the request from the server 1, and the other handles server B. Let's say it sends a request, and here there is a message, and also the destination, which is the mobile B. The server, since we know that the mobile B is a user of the mobile A, so the server A knows what to do. The server just create a thread to handle that. What it does is to push a notification to the mobile B. And in the meantime, it writes. So for the mobile on the local, of course, it has the record of this message. And the server wants to write a message to, well, it doesn't write anything to a database, it just sends a notification. And in this time, the mobile B, how it gets to know there is a notification, it uses a socket, web socket, which means it is listening. And whenever there is a push notification, it's invoked and it starts to accept this acknowledge. And at this time, it writes some of the message of this user B in the memory database. So it saves this record, and when the mobile B is online, this will send. When the mobile B starts to pull, the WebSocket will send this message, and it tells the mobile B where it comes from, and also the message which the user A wants to send it to it. So the overall architecture looks like this. In the scenario of a group chatting, it's a little different. What it sends to the server, it's similar, but now the server is like a cloud. When it wants to send it to multiple ones, it does not send it to just one destination, but multiple users. Here we send the message, but not the destination is not any one, but a group. Here we have the group ID. Once it's sent to the cloud knows what to do. So for each of those user, actually it has a backup. It's an in-memory database on the cloud, which means for each of the user, it has a list. Well, it should be a message buffer. For a second user, it also has this message buffer. What this does is just to fan out and notify, writes to the different buffers. Then the problem comes from why I cannot. So this is definitely a push notification, a push structure. Why cannot I use a pull, right? So for any writer, they do not write to the buffer, but instead they keep its own database, right? So here is a message. And when any of the user is awoke, they might wanna pull from the buffer, then the buffer comes to the members in this group and ask for the updates of the message. But the problem comes from every time mobile B puts the data, it's gonna talk to all of other members in this group. There may be 500 members. That means it's gonna read 500 buffers. That is just too many. So a better solution is to, which means the mobile B has to wait. There is a delay and it impacts the user experience. A better solution is to do it asynchronously. Whenever there's a new message writes to the buffer, well, when I say a buffer, it's actually a list of messages. And the message will time out if this list is too long. So the sender should send and find out it right away. Find out it means the cloud is gonna send to different local buffer, and this is actually a topic. So this is the publisher and subscriber architecture. The buffer will time out, which means if the mobile B does not get the message from this buffer, let's say the buffer had accumulated for 10 megabytes, then that's just too many. It's gonna just give up and do not send it to the mobile B at all. So this is for the one-to-one chatting and the group chatting. We've just discussed concepts like the pull and the pull. The WebSocket is used for the push notification. And in the group chatting, we use the fan out technology and we use the topic, publisher and subscriber architecture. Later on comes from the newsfeed. The newsfeed is like for anyone who can publish a photo or something. So regardless of the group, all of the friends of user A has the chance to receive the newsfeed. Similar to the group chatting, the friends of A has to keep a local hash so that whenever there is a message from the A or we say there's a news from A, they has to publish it right away. Publish and subscribe. Of course, there is a buffer. There are other buffers. Of course, for any user, there is only a limited number of friends. So for the WeChat, the upper limit is like thousands of friends, so that it does not have the problem of the Twitter when Justin Bieber publish news, then it's gonna be populated to millions of users. So for this one, when it publish a photo, video, of course, what's saved in this is just a URL. So what we save in this list are just a URL. We do not put the actual data here, but maybe somewhere else. Let's say it's saved in S3, right? So anyone can access the data in the S3. What is published to the buffer are just the photo URL and the video URL. When the mobile wants to get the data, it first pull the latest news from its local buffer. Of course, the buffer will time out, or when the list is too long, it's gonna remove some of the old messages. But it's fine because the messages are kept on the local database of the mobile B, which means just beware there's a local DB. For the local DB save both the URL and the video. But never mind. And just before we assembly the local database, what you wanna is first to get the URL, then we come to here to get the photo and the video. In this way, the user B can get the data, and on the mobile local, it saves the metadata and the actual data. So this is for the news feed. Do you remember that when you use WeChat, if you replace your phone, you move to a new phone, you do not read any of the group message anymore, right? Because the data will be removed right away. But for the news feed, they keep it for a certain period of time because there is a buffer, and the buffer lifetime is longer. Here, whenever the pull request has finished, the data are not saved in the buffer. That is why on the desktop application, whenever we log on the web app desktop, we do not have the chance to pull the data anymore. It's because once it's finished pulling, the buffer on the server will be removed. But for the newsfeed, it will be kept for a while. Okay, and then comes to the subscription. The subscription is designed to solve the Justin Bieber problem. The so-called Justin Bieber problem is just for well-known. It has millions of followers. If we continue using this architecture for whatever topic that it publish, it's gonna be fan out to millions of buffers. Just too many works. And for the S3, if we save the data here, there can be millions of requests to this S3 object, then that's just too many. So we can deal with the problem in a different way. We predict in advance which is a more famous user. In the WeChat, it's called enterprise user. And enterprise is different from a regular user. It's allowed to have millions of subscribers. When it publishes something, of course, it's gonna be populated into different buffers, but it has a locality, which means so for different subscribers in different city, or we say a different region, there is a cache. It's gonna be published to the local A and the local B. And before we write the buffer, there is a local cache server. Let's say in UK, there's another cache server. Let's say in JP. When it publishes to different locations. And the different cache will save them. So the next time that it's gonna be sending this push notification, it does not send from the buffer, but from the other notifications. So the notification in UK sends to the mobile B, and the notification in Japan sends to the mobile C. And for the S3, of course, since there's a buffer, we also have multiple S3. This is the S3 cache server. And also we allow to have another S3 cache server locally. Then the mobile B does not get the data from this local S3, but from another S3 from there. In this way, the mobile B can avoid getting all of the S3 from this location so that the traffic is not constrained, but distributed.